Right, today I'm going to teach you about computer programming or aircraft monitoring. No, computer programming. Right, so I picked up this question from codechef.com. It's pretty popular. It's from the easy practice questions, and I'll leave it on the screen for you to read, and I'll explain in the meanwhile. So the thing is that programming is basically 4 steps. 1, you read the problem. 2, you understand the problem. 3, you solve it. And then 4th, you get a computer to write it. Most people do the fourth one first. That's wrong. So we're going to read it first. I hope you've read it in the meanwhile. And we understand that there's a list of bulbs. They're all on. And in the first pass, 1, 2, 3, 4, 5, 6 till n are switched states. So if it's on, it goes off. If it's off, it goes on. Since it's the first pass, everything's on, so everything goes off. In the second pass, you go 2nd, 4th, 6th, 8th, and so on till you run out of bulbs, and you flip their states. Third pass, you go 3rd, 6th, 9th, and so on till you run out of bulbs, and you flip their states. What we need to do is find out at the end of n passes how many bulbs are still on. This is how we do it. I'm going to be using Python for the benefit of those who don't know programming, and because it's quite easy to read, basically nothing else. Idle is something you get with Python if you install it on Windows, so there's nothing to worry about there. Okay, first, inputs. What do we need? The question said we needed, alright, I'll just open it up beside this. The question said that we need n bulbs, so let's take n. And that's how you do input in Python. How many bulbs do you want? Let's take 100. Right? So you can check that. Right? That's fine. Now, we need a list of bulbs. What do we need in a list of bulbs? What are the properties of a bulb? A bulb has position, the first bulb, second bulb, third bulb, so on. It also has state. Is it on or is it off? So true and false might represent that very well, since it's only 2 states. So let's say true is on, false is off. So we create a list of bulbs, and very magically we call it bulb list. We said that every bulb is on in the beginning, so let's say true for I in range. How many bulbs was it? N. And we have bulb list. Length of bulb list is 100, so we know it's 100 bulbs. Alright, now we need to write the function, that is the function that goes over and over and over and switches on off the bulbs. How many times does it have to be done? N times. So we write a loop for pass number in range n. Right? Wrong. Range n will give you from 0 to n minus 1. We don't want that. In the first pass, we need 1. So what's going to happen? We need 1 to n plus 1. That gives us 1, 2, 3, 4, 5, 6 up till n plus 1. So it doesn't give us n plus 1. It gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So over here it will give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 100. It's not going to give us 101. So we have pass number. Now what do we do with that pass number? In the bulb list, we flip the state of the bulb if it is of the multiples of pass number. So let's say the pass number is 1. We flip the state of 1, 2, 3, 4, 5, 6 till n. And then if it's pass number 2, we flip it from 2, 4, 6, 8 until n. So we need pass number in this. So how do we do that? For bulb number in range starting from pass number up till n, and in multiples of pass number. So this will give us a list of bulbs. Let's say for pass number 1, it will exactly numerate 1, 2, 3, 4 and so on. How does it do that? It goes from pass number till n plus 1. So if it doesn't, if let's say it's pass 50, let's say 49, alright. So the first bulb will be 49. The next bulb to be whose state will be switched on off is 98, right? So after that it does not go, it doesn't go any further because the next one would cross n. So it goes from pass number to n plus 1 in multiples of pass number. That's what we need. Now what do? We go to the bulb list, the index. Remember, the index is from 0 to n, so you will need to, you know, adjust a little bit. Bulb number minus 1 because the index starts from 0 and the bulb number start from 1. So bulb number equals to bulb list, bulb number. Bulb list, the bulb number will give you the current state of the bulb and not. So that's gonna flip the state, and that's it. And we run the loop and we have something else. What does this mean? So over here what we can do is, you notice the error is bulb number minus 1. Get it? Bulb number that goes from 1 to n plus 1. So we won't have that. We have to do minus 1 here too. So you see what happens if you don't match the indexes correctly. We run that and we have something. Now all that is left is to actually see the list. For that I'm going to maximize the screen because it's 100 bulbs. So bulb list, and you see not everything is true. Something's false, something's true, something's false. So you see that what we need is the number of bulbs which are on, so the number of trues in this. So we have bulb list dot count true. Count how many times true occurs in this bulb list. Oh, I misspelled. bulb list dot count true. Oh, I again misspelled it. bulb list dot count. I'm gonna check it this time. Yep. So we have 9 bulbs. You can work it out mathematically. It's true. So next time you're programming, you should remember 4 steps. 1. Read the problem. 2. Understand the problem. 3. Solve it without a computer. 4. Get a computer. Write it. Thank you.